given, find the largest sum of elements not adjacent to each other present in an array. Find the largest sum of elements. That is your objective, to find out the largest sum of elements, but the condition given is the elements must not be adjacent to each other. Okay, so here take an example. Say we have 7 elements present in an array. The elements are like this. So what will be the answer? As there are a few number of elements, so by watching it carefully, we can see that if you consider 5, 20 and 18, that gives you the largest sum, where obviously the elements are not adjacent. So how can you proceed using a program? Here we follow dynamic technique. We know that there are several ways of solving a problem, like dynamic technique, greedy technique, backtracking, etc. In dynamic technique, we follow a policy where previous calculation is used for doing some calculation later. That means we save the time of calculating some same thing over and again. You see, it is a better solution to recursion. We know in recursion, a function is called over and again to do some task repetitively until a condition is fulfilled or violated. So every time you call the function, time complexity increases. In dynamic programming, we try to reduce the time of doing some same thing over and again by keeping the previous calculation, using it for some following calculations. Now coming to that problem, you see you have 7 elements here. As in recursion, we know some base condition is there. Here also in dynamic problem, taking that example particularly, say you have 2 elements here. How do you proceed? How do you move? See, you keep on doing calculations in respect to the values you have, fulfilling the condition, that means the elements must not be not adjacent. Find out sum, and when you are finding out the sum for the next value, you compare it with the previous calculation of sum, and if you find the later one is greater, you consider this one. So how it is possible? You see, say here we have the first 2 elements as 5 and minus 3. Initially, you take a array by the name S. What will be the size? Ignore it right now. Say initially the first index value is 5, AI is equal to 5, A0 is equal to 5. As it doesn't have any value or element previous, so you cannot compare with any previous value. So sum would be the first value, that means 5 is here coming as sum. But when you are considering I is equal to 1, the value is here minus 3 at index 1. Now what will be the sum you would take? You just compare this value with the previous value. If the value is greater than this previous value, you consider it. Otherwise, you consider the previous value. Mind it, you cannot take the sum of 2 adjacent values. So you are not adding these 2 values to get the sum. So what will be the sum here at index 1 of S? Either the value at index 1 or the value at index its previous. That means the previous sum. Either you consider the value at 1 or you ignore that value and take the sum calculated previously as the current sum. So the current sum is 5 because this 5 is greater than minus 3 if you consider the value, right? So these 2 values are taken initially without having much calculation. That means simply you are taking S0 as A0 and S1 as max of A0 and A1. That is straight, simple. Now, after these 2 values, you need to proceed from the third value. That means at index 2. And here we can have 7, 10, 100, 500, any number of values. So that what comes in our mind first, that is loop. We need to run a loop to do all the things, all the comparisons, the rest elements. So you run a loop from index value 2 to the end of the array. That means here you have n is equal to 7. So last index will be 6. So you go up to less than n and I plus plus. Enter into the loop. And what is your task? You need to populate that array with values. That means with sums. And how this sum would be considered? Again, you take an example here. Here we are at 2, at index I is equal to 2. So here you can do either of the things. Either you consider the value at index 2, that means 6, or you ignore this. When you are going to ignore it, because if you consider the value 6 here, you cannot consider the value at its previous index, that means -3. As simple as that, because it is the condition given to your program, that is you cannot take two adjacent values. So if you take 6, you cannot take -3. Now you see here at index 1 of sum, this value is considered by considering the value at index 1. Okay, because this is the location where you are having your sum calculated the latest. Now, if we don't consider it, we will consider that sum as the larger one. If we consider it, we will consider the sum as the larger one, considering this value as well as the value ignoring this one. That was sum ignoring this one. That means if we are considering I is equal to 2, then we would take that value. That means I is equal to sum up to I is equal to 0 plus the value at I is equal to 2. That means sum, that is 5, plus the value at I is equal to 2, what is giving you as 11. And if you don't want to consider this value 6 at I is equal to 2, then what will be the sum? Sum at I is equal to 1, that is 5. Which one is greater? Obviously this one is greater. So you are going to consider value 6 here. So the sum at index I is equal to 2 equals to max of sum up to the previous index and sum up to I minus 2. That means sum at the, ignoring the sum at the previous index plus the value itself. See, we just discussed Si minus 1 is 5 here and Si minus 2 is 5 here, as well as Ai is equal to 6. So 5 plus 6, 11. So which one is we are going to take? Obviously it is 11. We are going to take 11. So here it comes as 11. Now you just trim that your array that you have taken as example. If you have 5 minus 3, 6, what should be the answer? Answer should be 11, because 5 and 6 are not adjacent. You are taking 11 as an answer and we are getting it. But you proceed, you continue. Say now I is equal to 3. So we are here now with I is equal to 3. That means I is equal to 20. Come to that. Here it is. We are going to find out the sum at I is equal to 3. So what is the value of I minus 1? I is minus 1 is 11 now. So it is now 11. And your AI is equal to 20. And your I minus 2, that means considering the sum up to 1 is 5. So 5 plus 20, that is 25. So this is to be considered. It becomes 25. See, now again, extending our example by having 4 elements only, you have, so what will be the sum? 5 plus 20. You can follow it. 5 plus 20 is equal to 25. That is the largest sum you can have, fulfilling the condition. That means the elements are not adjacent. 5 and 20 are not adjacent. That will be the largest sum. You cannot take 6 and 20. Mind it, they are adjacent. That might be the largest, but you cannot take this. You cannot take this 5 plus 6 plus 20, because if you take 6 and 20, it will become adjacent. So 5 and 20, 5 plus 20 will be the right answer. Now again, you move. I is equal to 4. What would happen now? If I is equal to 4, Then Si minus 1 is 25 and Si minus 2 is 11 plus at I is equal to 4, it is the value is 2. So 11 plus 2, 13. Obviously, 25 is larger than 30. So we are not going to consider AI here. We are not going to consider that value 2 here, because up to I minus 1, here I is equal to 4. So up to I minus 1, that means up to index 3, the sum is 25. If you are going to consider that value 2, then sum would be less. So why should we consider the value 2? Rather, we would proceed with the previous sum. That means this 25 will be copied. That is dynamic programming. You are having your sum calculated previously. You are just using it. You are just using. You have I minus 1 calculated previously. You have I minus 2 calculated previously. You are just using it and comparing and taking the latest one. So 25 is here. It is copied here. You see, if I extend our example here, if you take 2, 5 minus 3, 6, 22, obviously the answer should be 25. It will remain 25 because you are not going to consider 2. If you consider 2, worst case you can have 5, sorry, best case you have 5, 6 and 2. That means 13. You got it. It is 13, which is definitely not greater than 25. If you take 5 and 20, it is obviously greater, fulfilling the condition. And now again you proceed, you go up to at index 5, it is minus 4. Again you will face the same problem. You see, when I is equal to 5 and Si, that means S4 is equal to 25, Si minus 1, I'm sorry. And if you take Si minus 2, that is also 25, but the AI value is minus 4, so it reduced to 21. Obviously, 25 is greater than 21. So again, you copy it here at index value 5. You copied here. So if you take minus 4, obviously you can see that minus 4 will not be considered as an element. Finally, I reaches at 6, which is 18. So here you have 25 at I minus 1, which is simply copied from previous index of sum. And here it is at I minus 2, it was for 25 plus 18, I is equal to 18, it becomes 43. So 43 is greater than 25. Obviously, your sum value is 43 here. So now you can see that here the largest sum is 43 by considering these values, that 18, 20 and 5, which are not adjacent. So you see how dynamic programming works. That is a single line. Now you see I am writing the code here as simple as that. The simple code is S0 equals to A0, S1 equals to max of A0 and A1, max of these two values, and for I equals to 2, I less than n, I plus plus, you enter into the loop and populate your sum array. The sum array must be declared whose size would be equal to the size of the array you have with elements. Say if it is n, is the size of the sum array would be the same. So AI is max of Si minus 1 and Si minus 2 plus, if you consider the value present in the array. As simple as that. That is your answer. And always in dynamic programming, the last value would be the answer, be it a one-dimensional array or two-dimensional array. Here in your example, this is a one-dimensional array. So when you finish your task, you can remember that is the value you have at the last location of the sum array. So that is your answer. So once you come out, if you are running with C++, then C out would be the AI, or you can say an minus 1, the same thing. That will give you the answer. That's it. Hope you enjoyed it. Thank you.